All right. Anybody else? Very great set of answers. Yes. So let me summarize it, what you have said. So big data is simply the data of very big size that you cannot process using usual tools. So we will talk about the meaning of big size in a minute. Okay. So the kind of data which you cannot process using usual tools, and the conclusion is that you would require distributed architecture to solve the problems. Okay, you would require distributed architecture to solve the problem, and that is that is probably the most important distinction between big data solutions and non-big data solutions. So every big data solution is is generally a distributed computing architecture. All right, let me show you what does it mean by. And also, the data could be structured, semi-structured, or unstructured. So when I say unstructured or semi-structured, so let me help you understand what does it mean by it. Structured means data where we know what are the fields and what are their data types. For example, in a database table, we know exactly what are the columns and what are their data types. Correct? While in case of semi-structured data, we know what are the fields, but we do not know what are their data types. Okay, we know what are the columns, but we do not know what are the data types. For example, comma separated format like CSV. In case of CSV, the we know what exactly is a column. We know we have a way of separating columns by comma, but we do not know the data type because CSV does not carry the definition of the data type. Third is unstructured. Unstructured is the case where we neither know the type of the we neither know the we neither know the the fields in the input nor we know their data types. Okay, so that is a quick definition of structured and unstructured data. Next idea is distributed computing. This is probably the most important definition. And why it's important? Because all of the tools that we discuss in this session, all of the tools, we will be starting with, say, Hadoop distributed file system, then we'll go with MapReduce, then we'll go with Hive, Pig, Scoop, Flume, Oozie, HBase, all of those, Spark and Storm, and all of these tools. There's one thing in common amongst all of these tools. All of these tools are having distributed architecture. Okay, meaning they run on many computers simultaneously to solve your problem. Okay, so what is distributed computing? A network of computers or group of computers which are networked together, which interact with each other, okay, and achieve a common goal. So some part of the work is done by first computer, some part of done by another computer, and so on, so that all these computers can solve your problem parallelly, and you don't have to rely on a single computer. And a group of computer is far more powerful than a single computer, meaning even if you have a supercomputer, if you have a supercomputer will not be able to give you a great throughput even as compared to five decent size servers. All right. Is everybody able to hear me clearly? I'm not seeing your questions. Great. All right. So now, what could be the reasons? What could be the characteristics of data or the problem which would force you to move to distributed computing, or which would force you to use big data tools. Let's understand those. Okay, so the first characteristic is volume. If the data you got to store is huge, the data you want to store is huge that you cannot store on a single computer in any way, then that's a volume related problem. Okay, if you are running a heavy traffic website, you would by now have realized that the kind of data that is generated by the website is not easily accumulated, is not easily manageable using a single computer, no matter how many drives you put in that computer. Okay, so that's volume. If the volume you grow is beyond that could be managed by using existing tool, you will have to move to a bigger solution. Let's say you have to store 100 terabyte data that cannot be managed using a normal file system, and that's where you say that we are not able to handle it using a single computer, or using single with the current architecture. We might have to go with big data solutions. And the examples of the data could be the storage of logs of website, storage of data by Gmail, for example, and Facebook has around 300 petabyte data, and so on. Okay, second characteristic second characteristic which can force you to adopt big data solutions is velocity. You launched your server and suddenly you got millions of requests to your server. You will not be able to manage these many requests by using one single server. You will have to go with a distributed computing environment. Okay, so because you will have to delegate the work to multiple computers. All right. Now, problems involving data coming at fast rate. For example, a lot of orders are being placed on your website and you want to churn them in real time. You want to prepare certain statistics in real time. And that is done, that is the characteristic called velocity of big data. All right. And all right. So that's the velocity. Third is variety. Okay, variety means the data in many forms. Variety also refers to the variety of problems. There are certain problems, or there are certain data structures which consumes a lot of computing. For example, given given a million emails, categorize them into 5 buckets. Okay, the problem statement doesn't have velocity, doesn't have volume, because it's just 1 million email. It'll hardly be 1 gigabyte data. But if you have to categorize it automatically, you'll have to process these 1 million email, and then it will take a lot of computing resources. And it'll be very difficult to get it done using a single computer in a reasonable time. Okay, so that is variety, the variety of data and variety of problems that you are trying to solve. Okay, so all the three things combined together. One is the data which is being accumulated at us, uh, which the huge data that needs to be accumulated. Second is the pace at which the data is coming and you want to process that. Third is the variety of problem and variety of data. Okay, so so either of these three characteristics, either of these three characteristics could force you to move to big data solutions. Okay, and then when you face these circumstances and you realize that your traditional solutions on a single node are not able to help you with any of these solutions, any of these situations, then you have to decide on moving to multiple computer systems or an architecture which is properly distributed, where multiple computers could be utilized to solve your problem. So that's about big data. That's about big data, data which requires a distributed computing. I will stick to this definition. I'll stick to this definition of big data, okay, as I go ahead with the rest of the classes. All right. So yes is saying, can you explain complex data structures again? Okay. Let me take the third variety part again, because it's very important to understand that part. Let me take another example this time. Let's say you have to find a path from one point to another in a huge map, and you want it maybe in 5 seconds or maybe in 10 seconds. Okay? Now, finding path in map does not have huge data, as in the volume is not in terabytes. It may be say 100 gigabyte if you are searching the map from one location to another location in a big country like India. Okay? So in those cases the volume may be higher, sorry, volume may not be that high. It may be, let's say, maybe 50 gigabytes, or maybe it go up to at most 100 gigabytes. Okay, finding the path in the map. Neither there is a velocity. The map is not changing so frequently, right? The third is the variety. So variety is there here, the variety of problem, because it's not a straight problem. You have to find all possible ways to reach to another point, and you have to find the shortest path. To do that, you will have to do all kinds of iterations. There are so many permutations possible, and therefore to reach out to the optimum solution you need to use really clever algorithms, that and that too over multiple computers. A single computer would take a lot of time to find the path from one position to another. Therefore, it might go into hours, or it might go beyond that. Therefore, you'll have to use multitude of computers to solve such kind of problems. I hope that answers your question. Yes, now. All right. So everybody clear about volume, velocity, and variety? Great, great. This is very important. So a quick question to all: how many bytes are there in a petabyte? All right. Yes, that's right. So a petabyte has around 10 to the power 15 bytes. The way you can remember is by remembering kilo, mega, giga, tera, peta, exa, zeta, iota, and each one is a multiple of the previous by 1024 times, 1024 times. All right. Now we have a good question. I think I would like to answer this now. Biswa's question is variety related to CPU intensive processes? Yes. Yes. Mostly the variety is related to the CPU intensive processes. So volume means the data would consume lot of disk IOs, as in the rate at which we are reading data from the disk. While velocity relates to the network bandwidth, and the third one, the The third one, which is the variety, relates to the CPU and memory. All right. Good, good. Great set of questions. All right. Now, here is a question to you. Now, we understand that 1 petabyte data is 10 to the power 15 bytes, and we know what is a big data. The data to or the problem for which we would require distributed architecture. So, question to all of you is, if you have to count just the vowels, if you have to just count just the vowels in 1 petabyte data every day, can you do it without distributed system? Yes. Can you do it without distributed system? Can you get it done without a system which is using multiple computers? And note the conditions. We have to get it done every day. Yes says that it can be done at great cost. Biswa says if the data is completely numeric. Okay. Otherwise, it may not be possible. Anybody else? So imagine that it's a strings of character. Okay, this is a lot of text, and you want to just count the vowels in this data every day. And this data is not increasing at a rate of 1 petabyte every day. It is there. All you have to do is you want to count you want to count the vowels in this every day. Yes. So Mamta's point is, if it is taking more than 25, okay, Mamta's answer is, it might take more than 24 hours, hence it's not possible every day. Brilliant, brilliant. Okay, so yes, Roshan's point is, as you have said, so we would need big data solution for this. Yes, that's a similar answer from Chandra. That we need we need to get this done with hundreds of distributed node with splitting data. Okay, so the point is here, why is it difficult or why is it not possible to get it using a single computer? Okay, the answer is that answer is in this particular question. Okay, so question. Okay, yes. Now, as opposed to our thesis that CPU, RAM, or something that gets that becomes the bottleneck, here the bottleneck is the rate at which you can read from the disk. Okay, disk is the round cassette kind of a thing. You guys must have used a cassette while playing the music. So hard disk is mostly like a cassette on which basically rotates, and the header moves on that kind of disk. So there is a physical limitations to hard disk drive. Okay. Now a quick question to all of you. How much time does it take to read 1 terabyte from a hard disk? Yes, anyone? All right. Mahesh's question is, it depends on the speed of the hard disk, seek time and latency. That's his first question. Ram is saying it takes around few minutes. Mamta is saying it takes around 8 to 10 hours. Give a estimate. I know that it depends on the hard disk. I want to see your assumptions. All right. All right. Good. Brilliant. So, yes. So, Yash and Mamta and Midhili are close. Okay. Good. It takes around 6 hours. It takes 5 seconds to read data from the disk. Read 1 GB data from the disk. It takes five seconds. So now you can imagine that to read 1 TB data from a hard disk, it takes 5,000 seconds. All right. So this is very important to understand. If you have a terabyte of movies and you want to copy, the fastest hard drives available in the market would copy it around 5 to 6 hours. Okay, so now when we churn 1 petabyte data and we were just reading the data from one side till another, we were not doing too much of jumping back and forth. Okay, the the amount of time that will take to read 1 petabyte data would be 6,000 hours. Okay, it'll take more than 6,000 hours. Now you can understand why we call that we 1 petabyte is a big data for these reasons. All right. So 1 petabyte is generally regarded as big data for a couple of reasons. First, storing 1 petabyte data itself is fairly difficult. Okay. So you have to distribute it across the cluster because you would require around minimum thousand of hard disks. Okay. Second is, even if you are doing the simple processing like counting letters in the counting a particular byte, still that would require a lot of computing resources, and therefore 1 petabyte is generally regarded as big data. All right. So this is one graph which shows how the data has grown. So digital storage has expanded after 2002 at a very fast pace, at an exponential rate. And the analog storage is not growing at that pace. Why is it so? Answer is simple. The devices have become cheaper, fast and smaller in size, cheaper in cost and faster with respect to ability to do work. So devices have become cheaper, faster and smaller. These three criterias are very important when we talk about any hardware device. Okay, so if you are from hardware manufacturing background, you would know that every uh, every hardware manufacturer has this target of achieving these things. Okay, those are their key performance indicator. Okay, so cheaper, faster and smaller, that is their key objective while manufacturing various kinds of devices. And in devices we have the state of art mobile phones, which are far better than the supercomputers of 2000s. Okay, supercomputers of 2002 was slower than the mobile phone as of today. Okay, so now you can understand the rate at which technology has grown. And on other hand, while the hardware devices were becoming so powerful, on the other hand, the connectivity between things have become very, very popular. Okay, there are Wi-Fi's everywhere. There are 3G, 4G, 2G and Bluetooth. There are all kinds of transport mechanism available as of today. These are all data transport mechanism. Okay, and to support these things, there are lots of softwares that have come in. So these are the three basic reasons why big data has grown so drastically fast. All right. All right. Roshan's question is, if reading 1 terabyte data takes 6 hours, then processing it will take more time. And so we can say that 1 terabyte is also a big data. Yes. In general words, we can call 1 terabyte as big data. But the problem is somebody will say, with I'm okay with 6 hours. I'm okay with 6 hours of processing. Okay, and or somebody will say that, okay, we don't process 1 terabyte data, it just is stored silently, right? So ours is not a big data problem. We can keep on putting it into different computers and then forget. For example, lots of people have movies in 10 terabytes. Okay, they just put it on very various hard disks and then forget. They don't churn the data. So they will say that we don't require a distributed computing, we are happy with our current disks. Okay, so that is the reason I avoid saying 1 terabyte as big data. Okay, for the political correctness. Now, which component do you think impact the speed out of A, B, C, D, E, F, G? Which components impact speed of computing? Think about any computing does, and think about these parameters. So do you think these components impact computing, or which of these components impact computing? All right, all right. So almost all of you, except for one person, says that G, all of the above. Okay. Yes, disk size also is important, Abhay. All right. So yes, all of these components impact the speed of computing. And you will realize that based on the problem definition, sometimes A will become bottleneck, sometimes B will become bottleneck, sometimes C will become bottleneck, and so on. And we will, as a developer or as an architect, you will have to keep on fine tuning your software. So and that fine tuning essentially means shifting the bottleneck from one place to another. For example, in your web server, you put caching. What does caching do? Caching basically loads the data from the disk and keeps it in the memory. Now, it does resolve a problem of slow hard disk, but at the same time, you have shifted the bottleneck from the disk to the RAM, to the memory, because now memory is full after you have started the cache. Similarly, sometimes you try to basically counter the disk size by, because you are not able to fit the data in a disk, so disk is becoming bottleneck. You put it in the network, the data in network. Now the network speed will become the bottleneck. So as a developer, as an architect, we keep on shifting the bottleneck for our program as much as possible, and there is a time when we realize that we are not able to get past the bottlenecks. And that's when we say that we cannot handle such kind of load, we cannot solve these kind of problems using a single computer, no matter how much optimization we do. And that is the time when we say that let's start with distributed computing. Yes. Uh, his question is, what data is cached? Is it static data? Yes. All right. So all of them. Brilliant. Great session. And yeah, a good set of answers I'm getting. All right. So this is something very important. Even if you are not from computing background, take a bit of time to understand how does it happen. So in a computer, these are the four components which are very important, which are connected to each other. So CPU is the main engine which governs everything. CPU reads the data from RAM, processes it, and saves into network or the disk. All right. Now, these are the four pillars of computing, you can say, and four things which are important for computing: CPU, RAM, disk, and network. Now, when we talk about network, it's only the speed of the network, while in case of disk, we talk about the how much disk size is there and what is the speed. Similarly, RAM, RAM speed and RAM size are two criterias. Okay, so out of these four components, out of these four components, at least one will become the bottleneck for a single for a big data. At least one of these four will become the bottleneck when we are dealing with big data. All right. And that's when you will say that, okay, let's have another computer in which we'll get one more CPU, one more RAM, we'll double the disk, we'll double the disk IO, we will double the disk, we'll double the network IO. So, so as we put in more and more computer, the idea is to multiply this hardware. And also, we need to break down our problem. Okay, we need to break down our problem which we are trying to solve such that it can be divided amongst multiple computers. We need to break it down into the parts such that one part can be solved by one computer while other parts is being solved by another computer. If you are not able to break down your problem, okay, into parts, you won't be able to utilize multiple computers no matter what kind of hardware you have purchased. And that's where it is important for developers, and it's important for architects, and it's important for anybody to understand how can we divide the work amongst computers. So till now the problem statement, when we studied databases, when we studied other technologies, till now the to problem was to get things done through the computer. Now the problem statement is how can we divide our work so that we can get things done using multiple computers. Okay. All right. So there are a few questions which I would like to take. I hope your guys are okay with that. There's a question from Biswa. And distributed computing should not be misinterpreted as multi-threaded processing. That's right. Multi-threading only solves one problem, that is the CPU bottleneck. It does not solve these other bottlenecks. Okay, if you have two CPUs in a computer and you have a big work, you can ask one CPU to do certain part of work and other CPU to do some other part of work. But the network is same, the disk is same, the RAM is same. So we are basically rest of the three resources are same, and we have only doubled this part. That is sometimes called parallel computing, or sometimes it's called multi-threading processing. All right. So I think that answers Rawson's question also. His question is, if we have a problem with one CPU, does having one or more cores like quad core or octa core systems help? So if let's take a step back, It's a very good question, and probably every one of you should pay attention to it. So, question is, what if we put more cores in the computer? Does it help? Does it help to to go with the very high end CPUs? Does it solve our big data problems? The answer is generally no. Reason is CPU is hardly ever the bottleneck. The first bottleneck you will encounter in your web server is the RAM. That's the first bottleneck that you will ever encounter. Then when you elevate the RAM as a bottleneck, the other bottleneck that might arise is disk IO. As we saw that in case of 1 terabyte data, it takes 6 to 10 hours to read the data, right? So the disk IOs become the problem more quickly than the CPU, okay, more quickly uh, than the other criterias. So increasing CPUs does not help much. It only helps the third kind of problem as in variety. Variety as in where we have a complex problem which where we need to go over the data again and again multiple times, even though the data is small, but we are going back and forth on the same data. In the third V is only solved, uh, slightly solved by increasing the CPU. Okay, I hope that answers your question, Rohan and Biswa. The question from Biswa is very good. I'll like to take it up as well. Question from Biswa is, with distributed computing, are we not getting more dependent on the network and hence network becoming the critical bottleneck throughout? Brilliant question. His question is, when we are connecting multiple computers, so will we not be busy in transmitting data from one to another all the time? The answer is no. And that's where the Hadoop architecture lies. That's where there's the biggest plus of Hadoop architecture. In Hadoop architecture, we divide the data across multiple machines and we do the computation of that part of the data on that machine. So effectively, the data transport is very minimal and most of the churning happens near the data on the same computer that contains the data. Okay, that was my quickest answer, and we will understand it more and more as we go into the details in the whole course. Every component make sure in Hadoop ecosystem that the network transport is minimal because network transport is even slower than the discrete write. Now, Yasi's question is, can this be applied to OLTP transaction breaking down? Okay, yeah. So, yes. Ashish Goyal's question is, distributed computing is much more than older than Hadoop. That's very right. That's very right. In 2002, we were handling a lot of data, the data of the size that could not be transported every week over the network. We had to bring it from New York till here via the tape drive. Okay? Via the tape drive, either by the air or by the ship. Okay, so the distributed computing concept is yes, definitely older than the Hadoop. Okay, we used to call it grid computing at that time. Mamta's question is, will same data be stored on multiple system? No, only the data will be sliced into parts and then distributed. This is a good question from Sindhu. Question is, do you mean to say that in a big data disk, in a big data, disk IO is a major bottleneck that demands us to distribute in more than one physical machine? I would say that that is just one part of the problem, the volume part of the problem. Okay, Sindhu. There are other two parts of the problem, the velocity and the variety. Variety makes the CPU and RAM bottleneck, while velocity makes RAM and the network bottleneck. All right. Okay. So Roshan's further question is, can adding more CPUs help if we are finding the most optimal optimal path? Yes. In that case, yes, it does help you. But again, there you the other bottleneck you will have is if you are churning huge data to find the path from one place to another. Other than CPU, your RAM will also be the bottleneck. So you'll need a huge RAM. All right. Krishna's question is, what is the difference between grid and SDFS? I think it'll be little premature for me to say. If you could send me this question, I will try to answer it. All right. Let me make a note of it. All right. Let me make a note of it. I'll answer it maybe on the forum. Abhay's question is, won't data be synchronized between the nodes? Yes. There are many dynamics to go into when it comes to data distribution. Sindhu's question is, based on Oracle experience, even if we add 64 GB RAM for 2 TB data, it is not fully used. Yes. Okay, but when you do a complex computing, think about finding the path from one location to another. Trust me, you will have to load a lot of data. The other case is, I remember in one of the problems which I was solving at InMobi, where we had a lot of traffic coming in and we were doing the real-time analytics. So we were thinking that, okay, we'll be able to handle it in the RAM, but you would not believe that we end up increasing the RAM to 200 GB, and still we could not handle that data. Okay, so yes, all right. Mahesh's question is, if one server goes down in a distributed system, do we keep a copy of data on that server so that we can process the data? Very good question, and very few little with respect to the current course, it's little a question which I would like to answer in second session. Okay, these are very good questions, and that's where I'm happy that I'm able to bring the discussion to that point. Okay, all right. Roshan is saying that you talked about volume, velocity, and variety, but not availability. Yes. So, yeah, availability could be another reason for. So, availability is generally considered as a backup. And in all of these distributed computing solution, those are the criteria. We call them resilience. We call them. There are many terms for the same thing. Okay, so Sindhu is saying that, yeah, there's a question from Sindhu is, won't there be a split brain syndrome if one machine cluster goes down? Yes, you should. Yes, that's where the mechanisms arise. I would if you go to YouTube and look at one of the videos of Zookeeper I have put in, that's exactly talk about how how to avoid split brain kind of syndrome. Split brain kind of syndrome, as in half of the brain is taking a decision and half of the brain is not. So that kind of problems are solved by using the algorithms like Paxos algorithm. All right, brilliant questions. All right, so let's move on. There are a lot of things to discuss, and yes. All right, so at least one of these will become bottleneck. Now, from the perspective of the customers, let's try to understand what is the point of handling such a huge data. We talked about data is growing. We also talked about how data makes the things complex, how things become bottleneck. We and The main question is why? Why do we need to handle that bigger data? Can't we just delete it and forget it and delete the old data the way most of the traditional people have been doing? That let's just delete the data and just focus on sample size or small sample size and do things. Okay. So the answer is that rather than thinking of data as a big pain point, think of it as a gold mine. And those who converted the problem into a solution, they are successful. For example, let's take the case of e-commerce. Okay, let's take the case of e-commerce where where the that is probably the very first use of big data. It's the recommendations. Recommendation as in based on a product or based on the user's behavior, you show them recommendations. So recommendations are like cross-selling. Cross-selling as in, okay, people who like this also like that. You may like to wear this with that. Now, this kind of insights are meaningful only if you have the behavior of so many people. Okay, a behavior of so many people gives you a better result as compared to a small number of people but a great algorithm. You come up with a great algorithm that okay, all these products with this kind with if I show you use this algorithm, then I can give them better recommendation. That will not result in that will not give great result. What will give great result is understanding human behavior by statistics, understanding human behavior and figuring out figuring out the common the what is it that people want to buy or people like to see, right? And that cannot be done by a single person sitting in a room. Unlike unlike the unlike the older times where one person takes a call, here let the data speak. All right, so the recommendations is one such game which proved that data is the strategy for an organization. The maximum money that Amazon makes, the maximum sales Amazon does is because of the recommendation. The kind of recommendation they provide to the end user is very, very useful. Here it says customer who bought this also bought this. It is very reassuring for a customer. All right. Now, and imagine the movie recommendation based on what kind of rating you have given. These movie recommendation system find out who are the people similar to you and then start cross recommending. As in, let's say me and you are very similar, it will recommend the extra movies from my side to you and extra movies from your side to me. Okay, and that's how the whole recommendation system works. So now you can imagine that the more the data you have, the more similarity you can figure out between the users. If you have small data, the chances are that you will have skewed behavior. Okay, and that is where people think of big data as a gold mine. Next is the search quality. You can improve the search quality if you understand what did people search and what is the common search behavior, and that can only be done if you have huge data in place. Also, to improve search quality, you might need to understand human behavior in general. For example, what kind of typing mistake people do occasionally, and what are the various synonyms for each word. And to churn these synonyms and to churn the typing mistake, you might have to crawl a lot of data. And the more you crawl, the more big data churning you do, the better your search results will be. Third is the sentiment analysis. So, sentiment analysis is something which we will talk after some time. So, all right, and then is A/B testing. What exactly is A/B testing? In A/B testing, A/B testing comes from drug testing environment where some of the people were giving the pacifiers, as in the just the simple plain water, no drug in that, while some of the people were the given the medicine, and then the impact of both was observed. Impact was observed on with and without medicine. Now that is why it's called A and B, control slash test. Control is are the people who did not were not given medicine, while test is the set or subset of the data who were given the medicine. Now this is called A/B testing, observing the behavior of your audience, observing the behavior of your sample based on observing the behavior of two samples, one which is not in treatment and other which is under treatment. This way you can confidently say whether a medicine is working or not working. All right, so that is about the A/B testing. For A/B testing, the bigger the data you have, the better the testing you will get. If, say, for example, in case of Amazon, even the change in buy now color, because I was in the same team who was responsible for detail page. If we had to change even the color of the buy now, we will use their internal tools to test it on the users. Okay, internal tools to test it on the user. So we came up with this brilliant idea and said, okay, let's try to display a flower next to the buy now button. I'm just taking a hypothetical case. So instead of seeking permission of my manager, of my designer, of my CEO, what we do is we used to display the new changes to very small set of users, say 0.01% of total users, and then see the feedback. Did it confuse users? If the users got confused, they will not buy. And then compare the results statistically. So we randomly select the users who we saw the new design and then observe. So this is called A/B testing. All right, and A/B testing is the only reason how Amazon, Google, Facebook, they continue to innovate. They continue to change their code base every day. Unlike unlike a services company where a change is a big deal. Here, because they have a A/B testing environment, a change is just a part of life. The only time we did not push to the production at Amazon was the Christmas time and that too in during Christmas time we actually pushed to other geographies like China and Russia and India. So 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 because of A/B testing, many organizations continue to innovate, and A/B testing makes sense only if you have huge data. Sindhu is saying, isn't it an email marketing term? So A/B testing is everywhere, starting with medicines to emails, email campaigns, or web analytics, or the what do you call product development. So everywhere, A/B testing is hugely used. Do There's one good question from Mamta. Do the AB users rate the change? How do they know whether they like the change or not? So we generally keep the objective very concrete. We do not let users to vote for it. Instead, we observe the behavior of users, because when you ask them to vote, you generally get very biased opinion. Instead, you observe their behavior. So we build a kind of a KPI, key performance indicators, such as how much time are they spending on the website after we have changed the theme. How much time are they spending, how many average page visits, and how much time on every page visits is happening in the new design. Second, has the purchase rate increased? Are the number of people who put into the basket, is it higher than the previous, the A in case of B, as in A slash B, or control slash treatment? So that comparison between their purchase behavior, how much time are they spending on the website, okay, and how much are they exploring? So those are the criterias, and we observe those criterias very closely. All right, I hope I'm able to answer your questions. Now, in telecommunication, there are many use cases of big data, starting with customers and prevention and network performance optimization, okay, and doing the calling data record analysis, analyzing network to predict the failure. All right. And then you have government, where you do the fraud detection, do the cybersecurity welfare, and do the justice. In healthcare and life sciences, you y- use the big data tools for health information exchange, gene sequencing, death, healthcare im- improvement, and drug safety. Drug safety is again a kind of A/B testing kind of environment. All right. Now a quick idea on how does the recommendation happen. This is very simplistic. It's a very simplistic model, just to alleviate the fears from your mind. So generally there are tools like Mahat which do the recommendations for you. And in the tool like Mahat is pretty easy to use. This tool basically expects you to give three-column data input, and it gives out the three-column data output, saying this is the user ID and he may like this movie and this much. Say Kumar might like Apocalypse Now by 4 out of 5. That is the chance of Kumar liking Apocalypse Now. So this is the way you generally generate recommendation in batch process. And Mahout is nothing but it uses Hadoop to do the processing for you. All right, we'll go into the details during the session. So we'll cover the this recommendation case completely in one of the sessions. And next is sentiment analysis. Sentiment analysis means you want to churn a huge data to understand where people are talking positive or negative about you or your brand name or your product or your new revision. So So the way you do is you plot negative sentiment and positive sentiment on a graph against the date. And then you also mark the very on this graph you also mark the date on which a product is one particular campaign or product was released. All right. These are the 11. So that was our sentiment analysis and recommendation and other big data use cases. Now let's talk about 11 common myths about big data. Big data it always means data above or in the range of terabytes. Mostly yes, but not always. Is always about social media doesn't apply to me. Not really. It just so happens that in social media the data is huge. That's why it's confused that it's always about social media. will replace EDW, Enterprise Data Warehouses. Okay, it will partly word, but not completely. The cases where you require strong strong relational data, then you will need to have the traditional relational databases. It's just a buzzword, no practical application. So this is something which I keep on hearing, but no. There have been practical implications to the way the world has worked because of the big data tools. Okay, because of this evolution where the big data tools are now available to even the small and medium sized industry and the individual freelancers like me, and we have been able to do a lot of things using using the big data tools which are available now. Okay, so it's not a buzzword. There are a lot of things have happened, are happening, and in case your organization is not moving or adopting to new set of tools, it's not good enough. It's you will be you are missing a lot. Okay, next is a new concept. No, as somebody else has also pointed out in the session, it has been since 1990s. Okay, and it's just that most of this technology was inside the closed room of few companies. Now it is public. And will be future? No, it is present. Is expensive? No. Almost all the tools are open source. It is just the people who are scarce. And now there are, a lot of developers are coming in into the big data development environment. uh, is only for big data scientists or is magic? Not really. It's not for data scientists only. Data scientists help you develop algorithms, and you could utilize those algorithms to manipulate big data. So if you are looking for data science course, then you have to understand the distributed computing as well. Okay, we have enough hardware, don't need any more. So it's not about hardware, it's just that there are few companies, one or two, who are selling their hardware unnecessarily. Why? Because it's not about hardware, it's about the distributed architecture. All right. So you don't have to buy hardware. It's actually the other way around. So most of the distributed architecture has been designed such that you can utilize the existing hardware. You can just network your existing hardware together and let it solve your problem. Okay. And we will build it when we need it. This is probably the most fatal statement which I hear from lots of people. The problem with this is if you think that you will build it when you need it, what would happen is when you need it, you would not have it. Okay, because the moment you realize, oh, I could have done this much of data analysis of my customer data, and I could have stopped my customer from leaving me. By the time you will not have storage, you will not have the data storage. Next is the big data is about Hadoop. No, there are many other tools which do the same thing as what Hadoop does. These are the salary trends across the industry. You can see still out of all the technologies, Hadoop is still the leading one, and it has been consistently going up. Okay, so that is why this goes. All right, all right. So you can also go to Indeed.com and go through the salaries, and the salaries are generally going up. This is based on April 12, 2015 data. All right, so you must go through that. Now there are right. So two more questions before we take a break. One question from Sindhu regarding EDW. Why is ETL tool integrated with Apache framework? Okay. So just give me a second. Let me answer this. There's only one question. So ETL tool integrated with Apache framework because Even ETL tool need to be of the behavior of distributed computing, maybe meaning transformation and transfer of the data has to happen in a distributed fashion. That's why Hadoop has to come up with its own tool to transfer and transform the data parallelly on using the whole network of hundreds of computers. All right. All right, then let's take a break. I will just put the slide which says break. So let's take a 10 minutes break and come back by 8:41 a.m. IST. Okay? All right. All right. So let's start then. All right. Should we start? Is everybody back? All right. All right. So great. Looks like everybody's back. Let's start then. Okay. All right. There are many big data solutions, as in the solutions that help you churn big data or store big data. Okay. So the first and foremost is, of course, Apache Hadoop, because that's probably the biggest ecosystem and biggest architecture as of today. So generally, Apache Hadoop and Apache Spark both are these days combined together. One for near real-time communication, real-time, near real-time churning of data, while Apache Hadoop is great for storage of huge data and and for and for processing batch-wise. So that's a combination of Apache Hadoop and Spark that is something very most powerful amongst all. Next is Cassandra. Cassandra is great if you are just looking forward to storing data in kind of SQL format, or MongoDB if you are looking for a big storage of data in the form of to store complex data as in data which has lots and lots of hierarchy. Okay, one object contains other and so on. So to store the data where you would like to have SQL, but the relational structure is holding you back. So MongoDB is good in those cases. But MongoDB or Cassandra, they don't have that kind of a rich library as provided by Hadoop and Spark. Then fourth one is Google Compute Engine. Google Compute Engine is something which is not in your office premise. Instead, it is in the Google's premise. You will have to transfer the data from your data center to Google's Compute Engine. And if that is okay for you, then you can go ahead with Google Compute Engine. Secondly, Google Compute Engine charges based on the computation. Therefore, be aware that Google Compute Engine might cost you more than what your own cluster does. Just that in Google Compute Engine, you don't need to hire anybody for DevOps team. Okay. Okay. A question from Mahesh. Could you please repeat the purpose of MongoDB? So MongoDB is like a database where you are trying to store a complex object or complex document, such as you have movies, who are the directors, what direct, and the details about the director. So a complex object, if you need to store continuously, then you go with MongoDB. Okay, all right. Roshan is saying, is Couchbase also in the same league? Yes, it is same league as MongoDB. It's just that Couchbase takes up more disk space than MongoDB. Sindhu's question is Google Compute Engine same as AWS? Yes, sort of. Just that Google Compute Engine provides you a good query language over the data. The difference with AWS is in AWS, it's basically a cluster. You can install Apache, Spark, MongoDB, Cassandra, whatever you want. So it's not it's more like appliance. It's more like hardware. Okay, in case of Google Compute Engine, the we upload the data and they provide a query on top of data. So Midley's question is Cassandra and MongoDB for storage purpose? Yes, mostly, but MongoDB as well as Cassandra, they provide their query languages with which you can query the data. Okay. Zubair's question is Spark free or is it licensed? It's completely free. Both have Apache license, and Apache license is a beautiful license. Apache license is beautiful license, and and because it allows you to use it for academic purpose, it allows you to use it for experimentation, it allows you to use the software to in the professional environment. Even if you are trying to sell your product which bundles Apache product, it's completely okay. It's completely okay to bundle Apache licensed product with your professional product. So that is the beauty of Apache license. All right. A question from Krishna. Krishna is saying, is SAP HANA also part of big data? I don't know. Honestly, I don't know. They have given selective access to only selective few people. And in the world of open source today, I'm not sure how do they stay relevant. So that is something. I know it's a harsh statement from my side, but in today's world, most of the technological innovation is happening around open source. There are proper licensed versions of Hadoop, even though it's free. There are properly supported organizations which are doing very decent. That is probably the new genre of development, and that is something not there in case of SAP HANA. The things are very close source. Things are very close source, and it drives away most of the innovators from the industry. That is probably the reason why I'm not able to include SAP HANA right now. Maybe it's a great solution. Maybe it's better than Hadoop, but I don't know. Roshan is saying, do we have a comparison table which helps us in selecting a technology for my special purpose or need? So that we do generally in the session number 11. When we are done with the understanding Hadoop and ecosystem, then you are in better situation to take a call. It's very important to understand a product before compare it with against another. All right. That's why we have kept a brief comparison of various tools available to us in session number 11. Sindhu's question is it is analytical solution? Is it? Yes. So basically, Google Compute Engine gives you ability to query the data. So it gives you the query and present the data. Prashant is saying, can we relate SAP BI with big data? How is BI related with big data? Okay, let me try to explain. So, business intelligence. So, his question is, how is BI related to big data? And then we'll talk about SAP BI. So, so BI is what? What do we mean by BI? BI means understanding data, trying to figure out how does my data look, trying to figure out the predictions, trying to figure out what happened in the last quarter and what might happen in the next quarter. Okay, these techniques are good and we are all happy till the point our data grows to a situation where usual BI tools are not able to handle that kind of data, right? And that's when the new genre of tools come into play. All right. So this is how BI is related to the big data. That BI would also require a big data solution, and that's why Hive and Pig come into play. Did I make sense, yeah, Prashant? All right. So that was a brief about solutions. Yes, Jubair and Biswa, you have question. You have raised hands. All right. If you have a question, feel free to drop a message. All right. Now let's do a quick 360-degree of Hadoop. We'll go through what exactly is Hadoop, what does it do, and what are the things to be taken care of while dealing with Hadoop. Okay. So first is there were there was a person called Dog Cutting who were working with Yahoo at that time as a hobby project. As a hobby project, he was doing something. He was trying to build a search engine like Google. And what is a search engine? A search engine downloads data from all websites, prepares indexes, and displays the search results to the end user. Indexes means just like the way given a book, you prepare an index at the end of at the end of the book. You will see the index of keywords. In the same way, Google prepares that index so that you can quickly search. Now, this index preparation is a humongous task. So and after index preparation, figuring out which one to display first is another humongous task. So when Dog Cutting was trying to build his own search engine, he realized that it was not possible to store that amount of data, because when he did the computation, he realized that he is going to need around around 2000 terabyte of data space to store at least the plain text of the world. Now, to have that kind of storage was almost impossible at that time using the traditional tool, and that is why he was kind of partly stuck. Luckily, Google published the three papers at that time. Those three papers were Google File System, Google MapReduce, and Google Bigtable. Google had already solved these problems, so all Dog Cutting did was, along with Mike Caffarella, he implemented those three papers as in the papers generally detail each product, so there were sufficient details with which he was able to build Hadoop. So in the beginning, Hadoop only had three components. Okay, three components inspired by three papers of Google. One was Google File System, that is the basic one. Second was Google MapReduce, and third was Bigtable. So one was file system, other was kind of an operating system or kind of a computation system, and third was the database. So, and that's how the birth of Hadoop happened. Now, it was Hadoop was the name of a toy elephant which Dog Cutting son was playing, and there was a very great decision he took at that time. He made the solution open source. There were many people who were trying to do what he was trying to do, but most of them kept the product as proprietary. Now, he made it open source, and that's what changed everything. Okay, and that too under Apache license. So that quickly gained a lot of adoption. Quickly, a lot of people started contributing to it, and and very soon Hadoop became quite an industry standard. It became popular, powerful, and supported. It is a framework to handle big data. All the components under the umbrella of Hadoop are for reliable, scalable, and distributed computing. It's written in Java. Now, the point number H, please pay attention to the point number H. It is for reliable, scalable, and distributed computing. What does it mean? What does it mean by reliable, scalable, and distributed computing? Reliable means in case one computer goes down, we should not get hurt. Second, in case you require more, in case you require more computing tomorrow, you should be able to add one more machine to the network. You should be able to add more resources to the network whenever needed. This is scalable. It should not be that when you are changing number of machines, suddenly you realize that, oh, we need to buy suddenly you realize that, oh, we need to re-architect our solution. Okay. So, and third is distributed compute, all the components that are under Hadoop umbrella. So Hadoop started with these three tools which I mentioned above. As of today, there are around 15 tools, 15 20 tools under the umbrella of Hadoop. Okay. Hadoop has itself become a directory of projects. Now, it's written in Java so that it can run on any kind of platform. All right. That has been a good decision because Java runs on many platforms. All right. Now let's talk about. All right. So Biswa, this is the brief about ecosystem. I will go through one item at a time, and then Sindhu is saying, isn't Spark part? It is. Spark is part of Hadoop ecosystem. All right. Now let's talk about the various component under the Hadoop ecosystem. All right. So the life of Hadoop begins with the Google file system, where they took the Google file system and implemented it. Why? Because storing data on a normal file system became almost impossible. Because we are talking about hundred thousands of terabyte data. So like you have in your computer C colon or D colon or E colon, it's a file system. In the same way, Hadoop distributed file system is also a file system where you create folders, you store files, you upload files, you download files, you delete files, append to the file, and overwrite a file. So that's Hadoop distribute. What is so special about Hadoop distributed file system? Why did we need it? Okay, the answer is very simple. Storing data on many machines brings in a lot of complexity of finding where is my data, finding basically distributing data and lot many. So and and to the end user, giving a simple interface is almost impossible using traditional tools. And that's where HDFS comes into play. HDFS runs on hundreds of computers. So inside HDFS, there could be hundreds of computers. And to the end user, it looks like a beautiful single folder. All right. That is Hadoop distributed file system. So it provides you a lot of functionality, okay, such as even if few computers are down, still you will be happy with the file system. Okay, so it provides you this brilliant brilliant way of distributing data and brilliant resilience in the sense that in case one or two computers die out, still it will work happily. Okay, next is Next is on top of Hadoop distributed file system, we need to do computing because in Hadoop distributed file system, data is sliced and divided on hundreds of computers. Okay, and which means some part of the data is on one computer, some part is on another, some part is on third one, and so on. Now, to churn this data, to run code on top of this data, or to run the code in this cluster, in this network of computers, you needed a kind of an operating system to which you can give your command and tell, hey, run it on all machines. Okay, that's what is Yarn. Yarn helps you achieve that kind of ability to figure out which machines are free, which machines are busy, run a code and get the results. That is Yarn. Now, Interacting with yarn is difficult and very low level. That's why the paradigms like MapReduce and Spark are formed. Spark is a component which can run on top of yarn and does the guidance to yarn that, hey, run this program on this machine, run this program on that machine, and so on. Whatever the result, to combine it on third machine. So that kind of work is done by yarn and MapReduce. So that kind of work is done by yarn on the orders of either Spark or on the orders of MapReduce. Now, so you as a developer either write the code for MapReduce or you write the code for Spark. Or sometimes if you are building your own platform like MapReduce and Spark, you basically write a code that will interact with Yarn directly if you're competing with MapReduce and Spark. All right, so that is the computational ecosystem on top of the data. The beauty of these computational engineers, they try to execute the code near the data. They try to execute the code near the data. All right, now there is something called HBase. HBase is like a database. In HBase, you can store millions of columns versus millions of columns and billions of rows. And NoSQL, this HBase will not will not bother you. It will be able to handle billions of rows and millions of columns, okay, which existing databases cannot. So HBase is kind of a very huge table which has columns and which has rows. You keep on adding data in that form. A- while HDFS is for storing files. Storing files as in you have got plain text file, any data you have, you can dump it on HDFS. But in case of HBase, you have to do the tabular manipulation. Okay, when you have to do the tabular manipulation, HBase is the solution. Okay, now on top of it, you have Hive and Piglatin. Now, most of us are okay with, some of us are okay with coding. Some of us are okay with writing program, for loops, this and that. Okay, but most of us are not comfortable with the coding. Also, coding is a time consuming and error prone exercise. If you compare writing a code to do the joins between the two tables as compared to writing a SQL query, you will realize that SQL query is far more efficient and far less time consuming and far less error prone. Okay, so SQL is far better than writing the code. So if you are talking to MapReduce, you will have to write the code, but if you are talking to Hive, you will have to write SQL, and that SQL internally gets converted into this code which will be executed on MapReduce. So you'll write SQL, and internally that becomes MapReduce and gets executed on the cluster via yarn. Okay, so you ask Hive to execute your query. Hive asks MapReduce to run the code which Hive has generated. Hive has converted your query into some code, and then MapReduce has asked, MapReduce would ask the yarn to execute its MapReduce logic. The MapReduce logic will look like, okay, here my program, run the map on these machines. Here is my program called reduce. Combine this data using reduce. And these instructions will be given by MapReduce to yarn. All right, so it's a layer of things. So if you are from database background and you are not very confident with the coding, or honestly, if I also, even though I'm a good at programming, but most of the time I would go with Hive kind of tools which can do the data churning for me quickly, and I mean, I don't have to write so much of code. Okay, because code is error prone, code is tedious, and code takes time to do. Okay, next is, so similar to Hive, when people realize that we require a new kind of language which takes care of the distributing computing. Okay, so similar to Hive, somebody came up with Pig. The quality of Pig was that it had quality of Pig was that it is basically SQL broken down simple steps. For example, in SQL you have group by, where group by you do the aggregation as well as grouping in a single shot, right? So Pig guys, those guys who built Pig, what they did was they took SQL, made it extremely simple, one statement at a time. You first group and then you aggregate. And that made a drastic difference in the way we do the distributed computing. So Pig is basically also good for analysts like Hive, that they can type their SQL query kind of a language and churn a lot of data. Okay, now, a big question which will be pounding in your head is, why am I running the SQL query when I can run SQL query in my usual database? The simple reason is, when the data grows bigger, your SQL query on your SQL database will not be able to sustain. Will Your SQL database may not be able to handle the kind of data which is required. Okay, so when the data grows big, you go with systems like Hive and Big and Hadoop and all of this in order to churn your data. Now, there is one new set of things that has came up called machine learning, or new genre of analytics. It's called predictive analytics, meaning predicting based on the past data. Earlier, it looked like a fancy thing, but now it's real. In I remember in 2003 2004, nobody was going for artificial intelligence or machine learning kind of courses because they were too theoretical. Now, because of big data becoming the mainstream, people realize that the machine learning or these intelligent algorithms make a lot of sense. They make a lot of sense because we have huge data, because these technologies, machine learning and artificial intelligence, they required lots and lots of data in order to give the results. Okay, so that's where Mahat comes into play. Mahat is an machine learning library which does a lot of magic for you. As I gave you an example while explaining recommendation engine, that there were three column data, you feed it to Mahat will give you the recommendations. In the same way, you could do a lot of things using Mahat is a collection of algorithms or collection of commands which do many things, such as predictive analytics, meaning predicting things based on the past; machine learning, as in same as predictive analytics, okay, in technical terms. So in machine learning, so you take the input data, you try to predict the future based on the past. That is machine learning. And predicting the future of the based on the data requires you to understand and figure out the current data. So that's very much possible as of today, to predict the future based on the past. Okay, provided you have good data. Next is, so in case of machine learning, you generally don't write the algorithm. Instead, you basically utilize the existing ones. All right. Next is that Flume and Scoop, the one that are at the bottom here, called Flume and Scoop. What does it mean by Flume and Scoop? Flume and Scoop are the tools to import data to Hadoop. If your data is unstructured, or if your data is kind of a real time, you go with Flume. If your data is coming in real time, then you basically start Flume agents and they will start pumping the data onto Hadoop. Flume is more like a pump. Okay, Flume is will suck the data from all the network and will push that to Hadoop, as in it is generally saved on Hadoop file system, Hadoop distributed file system. So Flume makes it possible to copy the unstructured data from the network to Hadoop ecosystem, while Scoop helps you transfer the data from relational databases into Hadoop. Okay, Hadoop as in HDFS and HBase. So that's pretty much about the ecosystem of Hadoop. Now, there are two more things I want to discuss here. In a larger project, like say the project I was talking about, like recommendation engine, what would it involve? First, it would involve you to copy the data using Scoop. Sorry, using Flume, because you will be copying the data from the raw data files. Now, once you've copied the data, next thing you will have to do is you'll have to clean this data. You'll have to massage it. You have to figure out the columns. You have to figure out what data to remove and all that. Now, once that is done, and that will be done mostly using Pig or Hive. Okay, and once that is done, okay, once you have cleaned the data, you have done finished with ETL, and you have just ready for the next step. Then you might require tools like Mahot to actually produce the map reduce, and once actually produce the recommendations. So Mahot will produce the recommendations for you that from the data you have cleaned, right? So you used Flume, you used Pig or maybe Hive, and then you use Mahat, and afterwards, and all this time you're using HDFS. After Mahat has done the job, as in Mahat has generated the recommendation, you will have to take it to your web server so that the data could be displayed on that server. Okay, Mahat could display the data. Mahat could generate the recommendation that will be taken to your J2E server or your PHP web server, where it will be presented to the user. So taking the data in the form of columns and rows from Hadoop to your web server would require tool like Scoop. All right. So that was pretty much about Scoop and Flume. Now, sorry, when you had a problem like recommendation engine where you had many steps starting with bringing data with Flume, cleaning with Pig, running Mahat and taking it back to Scoop, and so on. When you have these 4 or 5 steps, to run it manually is not possible. Therefore, you use tools like Uzi, which does the workflow for you. They do the workflow for you. All right. Now let me take up the question. And the user or the developer can interact with this cluster using either command line interface or Java or Python and other programming language. All right. Any questions at this point? I see a lot of questions right now. So Sindhu's question is HDFS similar to NFS? No. Okay. All right, it is not same as NFS because NFS is nothing but bunch of computers connected together in the network, and then we started storing the data from the remote. Okay, that is NFS. Ashish's question is, please repeat Yarn. So Yarn is more like an operating system. You ask Yarn to execute program on the cluster, and Yarn will do it for you. Or you will ask Yarn that, can you tell me which computers are free? I need to get this thing executed on those computers which is free. Or you would ask you, when I say you, it could be your MapReduce logic, your framework like MapReduce or framework like Spark will ask Yarn. Now there is a question from Sindhu. Question is, the question is, If we use HBase, we need to use we no need of HDFS, isn't it? Now my question is, do you need C colon when you have MS SQL? Well, HDFS is a file system like your C colon, okay? And HBase is a database like MS SQL. The way MS SQL stores its data in C colon, in the same way HBase stores its file, the data files in the HDFS. Was I able to answer, Sindhu? Jubair? Yes. So Jubair is saying HBase is for DB and HDFS is for file. In very simple words, when you want to present or manipulate your data very frequently, then you go with HDFS. If you are trying to just append the data, if you are just trying to append the data, then you go with file system because modifying a file is a very big headache. Chandra's question is very good questions. Does Hive stores objects in its own space or it points to HDFS? It points to HDFS, the second part. Alright, it points to HDFS. Alright, so there's a question from Prasant. Question is why HBase is named NoSQL? Okay, in very simple words, HBase is not able to provide you the structured storage. Okay, it's not able to provide you a relational properties. Okay, so databases like HBase are called NoSQL because first they cannot adhere to the SQL standard. They are for distributed systems. They are for handling millions of requests, and they can scale to a very huge data. Okay, and such databases are called NoSQL. A question from Yash is how is debugging done given there are so many layers? Okay, so debugging is done. That's a very important question. Yes, I'm happy you asked. So debugging is done first, just like the way you do the remote debugging in case of web servers. In the similar way, you could do debugging of the program which is running inside Hadoop. All right. The second level of debugging. So remote debugging is a concept where you can remotely hook to a running program and then make it walk through step by step. Okay. So that remote debugging is there for almost everything. Second kind of debugging is via the file systems, meaning the program keeps on logging into a folder, keeps on putting the error logs or access logs into a folder, and then you can go through that. All right. All right. Next question from Krishna is if one file system of HDFS is corrupted or not stable, what happens to chunk of data that went to that file or system? How to get so generally whenever files are stored in HDFS, there are three copies of it. Okay, if time permits, I'll go through it. All right, three copies of it. If one gets corrupted, that is disregarded, and a copy generated from the other copy. Okay, so yes, he's saying, is it like IBM Watson? IBM Watson is a little different league together. So most of the logic is the learning is with IBM Watson. You can use their API to retrieve the data from there. So Chandra's question is, do you cover machine learning algorithms in this course? No. This is a software engineering course, so machine learning algorithms will not be covered. Where does Spring XD fits into the picture? I'll have to look into it. Okay, I don't have the answer right away. All right, I'll just mark it to do. Does Spark take data from HD? Yes, very good question, Mahesh. Yes. The beauty of Spark is that it can read data from Hadoop distributed file system, Cassandra, HBase, MongoDB, probably everywhere. Okay. This is one thing sorry. Oh, I read it Spark. Okay, I read it Spark, but anyway, let me just make it Spark also. Yeah. So Spark, yes, can read. Similarly, Scoop takes data from DB to HDFS and also to FB. Yes. With Scoop, you can transfer data from normal database to HDFS and as well as to your HBase. Okay. Good question. So Biswa's question is, if the data is sliced into many pieces and stored at various locations, distributed file system, any change in the data must run. Yes. Must also run in every place. Yes. Okay. We will talk about it in a while. Let me just finish the questions. Can you all elaborate on Uzi? So Uzi is basically a kind of workflow tool. When you have many things like in a typical programming project, if you have many steps to compile, that copy this file, replace this with this, and when you have many steps, you have systems like Ant and systems like Make or Maven, right? They do the execution and compilation of various things for you. But similarly, in case of big data, you have Uzi kind of systems which take the workflow and execute the various things in a sequence. All right. Jubair's question is, can you explain HBase again? If it is a DB, why it is not in HDFS? HDFS is not a database. HDFS is a file system, like your C colon or D colon in your file, right? We needed a new file system so that we can store data on a network. Okay, while HBase is a database. Makes sense to you? Like you have MS SQL, the MySQL, that is kind of HBase. Sindhu, what exactly is the question? If that be the case in Oracle, we store data in database. What? Okay, okay, I think I'm getting it. Yes, we store the data in database and images in file system. That's how you can also look at it. Mamta. A question from Sorry, a question that was Sindhu, and question from Mamta is: does MapReduce and Spark do the same kind of job? Yes. Okay. So yes, MapReduce and Spark do the same kind of job. So question again with Spark HD. What is Spark HD? I don't know. I'll have to look into it. All right, I'll have to look into it. Now, Sindhu's question is, what is the real use of Hadoop framework for big data? There are, I mean, almost everything is possible using Hadoop framework on big data. All the use cases which we discussed for the customer, they can all be solved using the big data. All right. So all the things we talked about earlier, the big data customers, all those kind of things are basically the real use. If I have to develop a okay, if I have to develop a prediction engine to find the most optimal path out of available many paths available, and the data is collected from huge data, then is the following selection of technologies okay? Yes. Okay. So you might have to code a number of things on MapReduce. You might have to figure that out. Okay. Yes. A question from Abhay is that data in HBase would be stored in in data files. Ultimately, yes, it will store in HDFS. Okay, HBase will store the data in HDFS. All right. Sindhu is saying in Oracle we have pointers to the file system. Okay. Yes, that's right. How do you transfer the file from Hadoop to App Server? You can use the Hadoop client, okay, to copy the file from the HDFS to this thing. There is a Hadoop command line. All right. Ashish's question: why do we really need HBase? When you have a lot of modification going on in data, then you use HBase. If your need is only append only file system, you can continue to use HDFS. Okay, Mahesh. Okay, is it two-step process or one step? Yes, there will be many steps involved, not only two steps. Okay. Mithili is saying, do we have any utility to read data from MOLAP system like SBase? You There will be. If you can read from Java, then you can read using Scoop for HBase. Okay. All right. Yes, that's right, Mahesh. When you have a problem like this, the one you have described, you'll have to do it in steps, and that is why it's called batch-oriented process. All right. Mamta is saying, is Uzi a job scheduler? Yes, it has a job scheduler as well. It's called coordinator. Abhay's question is, why do we have HDFS and HBase separately? I think we have discussed it already. Let me try again. So why do we have file system and databases differently. Okay, so on file system, you write the data where you are only appending the data. If you are constantly modifying the data, then you put the data in database. All right. So the distinction between file system and database need to be very clear. File system is great for non-tabular data, while HBase is great for tabular data. Does HBase interface with Yarn? Yes. HBase does interfere with Yarn. HBase also provides you a way to query using MapReduce. Okay, a question from Abhay. I hope you got my answer. Can I use Hive with HBase? Yes. Who can use HBase, Hive, MapReduce? Okay. If you are trying to store a lot of data in tabular format, use HBase. If you want to query the data using SQL, you use Hive. And if you want to write program because your um, existing query language is not sufficing, in that case, you use MapReduce. Now, Chandra's question is, does Yarn act as a job scheduler similar to Uzi? So, Yarn can be called as a job scheduler, but not job scheduler. It's a scheduler. It schedules our work on the cluster. Now, Mamta's question is, how is data transferred to HDFS? Is it via Hadoop client? Yes, it is via Hadoop client. There is a Hadoop client called Hadoop command, and you can use Hadoop FS, Hadoop space FS. Can you query HBase? If not, HDFS. Can you query HBase? If not, then HDFS is the way to go. So HBase does not provide you any query language. It provides you a way to store data in a tabular format. Using a table, what does it mean by a table? It means it has got row and columns. When you put something in table, it implicitly gives it a structure. Okay, and that's the big difference between table structure and the file system. File system is a continuous bits of data which are written out there. What Chandar's question is, what do you recommend process slash transform files to transform files from different FTP sites to HDFS? I would recommend Scoop in this case. All right. Roshan's question is, if I already use MySQL to store my data now, how do I transfer to these technologies? That's where Scoop comes into play. Okay, that's where Scoop comes into play. All right. So I hope I have answered your question, Sindhu. All right. Great. Great. Now there is one more question. There are two more questions. Okay, one question from Krishna is, we can say yarn is similar to load L or transform is in grid. Oh, I did not get the question. Yarn is, we can say yarn similar to load L or platform is in the grid. Okay, I did not get this question. Maybe a typing mistake or something. Now Mithili's question is, can you please define what is Spark and its role? Okay. Mithili's point is that can you define So Spark is a new form of MapReduce. When you have to churn data, when you have to churn data at a very fast rate, then you generally use Spark. We will go into the complete 2 hours class with Spark, okay, and we will interact with it. So Spark utilizes lot of RAM in order to solve your problem. In case of MapReduce, MapReduce used to read data from HDFS and write data to HDFS. For every process, you have to first read the data from HDFS, write to HDFS. Okay, Spark broke the process into multiple steps. Spark made it possible to do all of the steps in the memory rather than saving everything again and again to the disk. So that way, Spark optimized the process. All right. Mahesh's question is: does HBase store data in plain text or store format similar to SQL? Yeah. So internally, the HBase, just like any other database, internally they store it in the file system. But it stores in a byte format. It is not a plain text format. When it's storing to the disk, it stores in bytes. It's a binary format. Okay. Yes, you are right in the sense that the format will be similar to SQL database. Okay. So Krishna's question is IBM load leveler or IBM platform LSF for grid. I'll have to do a study. This is little newer to me. I've not used these tools earlier. Okay, Krishna. And will you be taking about each component in detail in the upcoming session? That's Mamta's question. Yes. Thank you, Mamta, for asking this. Yes. All of these components, we will go into the details, okay, into the details, all of these components whatever we have talked about today, along with one more component called zookeeper. So Sindhu's question is, in memory cache means Spark? Kind of, yes. Spark provides you both functionality as in persisting things in memory as well as in the disk. All right, brilliant set of questions. So I have still 20 minutes left. So what I can do in these 20 minutes is, one, I can give you a quick demo of the Cloud Labs. Okay, that should give you an idea. Okay, so let's just go into one of your courses. All right. So, okay, another question I would like to answer before I jump into the demo. So, a question from Abhay is: will we be talking about HDFS during this course? Okay, so we will because HD sorry will we be talking about HD Insight during this course. Now, first let's understand what does it mean by HD Insights. HD Insights means Hadoop made run on Windows. Since Hadoop was already built using Java, so it was very much possible to run it on Windows. Just that the scripts that start and stop and those whole mechanism of starting and stopping was written in the shell and was not really working much on the Windows. So Hortonworks, in collaboration with Microsoft, launched HD Insights, which work really well with 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 Microsoft Windows. Okay, so basically, as of now, Hadoop runs very well on Microsoft Windows as well. And what was that tool? Uh, so okay, so and after it was made run on Windows, then people were able to run Hadoop on Microsoft's clusters. So we'll not be talking explicitly about HD Insight. We will be talking about the common tools that are run on HD Insights. Right? So Krishna is saying even as SAP HANA is also in memory. Okay. So Sindhu is saying yes. Is Hue covered? Yes, we cover Hue as in Hue is a great tool to use. Hue is a great tool via which you can use other components. All right, we will show you quickly today if time permits us. So Mahesh is saying on what operating system can Hadoop be installed? Hadoop can be installed on any Linux, Unix or Windows as of today. Yes is saying what which is more popular, Cloudera or Hortonworks from certificate point of view. Cloudera is little more popular than Hortonworks, but I like Hortonworks certification because Hortonworks certification focuses more on hands-on exercises. Right? What about Impala? We will not be covering Impala in this. Okay. Impala is not something which we are covering here. We'll just give an overview. All right. So let me just quickly take you through the HDFS. Okay. Let me just take you quickly through the HDFS, and then if time permits, I can give a demo of the cluster. Okay. All right. So HDFS is a component which stores the Hughes data for us. Okay. Let me just cover it really fast so that I get some more time. All right. So if you have thousands or hundreds of terabytes of data, how would you store it? Generally, the way you stored it in you connected all the computers together in the network and created folders on that and started storing. But the problem with this kind of model was the failovers and backup was pretty poor. You could not distribute the data uniformly. It was not basically good value for money, and scaling out was impossible. Okay. Now that's where you go with HDFS. You have in HDFS, you have two kinds of systems. One is called name node. Rest are called data nodes. Okay. Name node stores the information about the where is which file. Okay. So name node keeps information about what is where, meaning it keeps only the metadata information. Metadata means data about data. So in a cluster, in a HDFS cluster, as in cluster means many computers connected together is called cluster. So in a cluster, one computer is designated as name node and rest are data node. This name node knows which data is where. Okay. This is and all of these data node or name node, they are system processes like programs running in background listening on a particular port on a computer so that you can talk to them by talking on that port. Okay. So that's about a service. So all of these programs are a service, and this data which we are talking about here in the case of name node is in the RAM so that it is very fast. All right. Now the data is broken down into blocks. uh, Earlier it used to be 64 MB, but now it's 128 MB. So every big file is sliced into smaller files and distributed onto the data node. Okay. So data nodes store the actual data. Name node stores the information about what data is where. And this data, whatever file you store in this system, is sliced into small parts internally. If you guys have used torrent ever to download files, torrent also splits the data into small blocks, and so that the transfer can be fast. Okay, so in here also, if you are storing 1 terabyte big file, HDFS will not have a problem with it. It will consider as the file made up of so many small files. Okay. Now, why did it break down the big file into small files? So that big files can fit into small disks. Similarly, it leaves less unused space on the disk, optimizes the transfer, distributes the load to the multiple machines. Okay. Now, each of the block is copied to multiple machines so that if any of these machines go down, you still have the copies left. And using the remaining copies, the data is again brought to the same replication level. Okay, a replication factor is by default 3, meaning every block is copied 3 times. If you have 3 terabyte of disks connected together in a network, you can effectively store only 1 terabyte data, because that 1 terabyte data will be copied 3 times. Also, this replication can be controlled. One file can be uh, can be said that, okay, I just want 2 copies of this file and I want 10 copies of this file. Okay, so that replication factor can be controlled. Also, please note that no 2 copies of the data are on the same machine, which also means that you cannot have 3 replication if you have only 2 computers. If you have only 2 computers, you cannot have replication factor as 3, because for replication factor of 3, you need 3 computers, because no 2 copies of the file are on the same node. Okay, so if one data node fails, the data from other blocks, the lost blocks, are copied to other nodes. Okay, so let's say there were A, B, and C computers, and you copied one file, and the A, B, C, D, let's say A, B, and C, D. Let's imagine there are these 4 computers, and when you store the data, 1 copy went here, 1 copy went here, 1 copy went here. This is a replication of data, 3 copies of the same data. Now, after some time, what happened was this node went down. This node went down, so we are left with only 2 copies of the data. Using these 2 copies of the data, you can have quickly, what Hadoop will automatically do is quickly create one more copy. The moment it realizes that, okay, this file, this particular node is gone down, all the data that is lost here will be regenerated from other copies, and thus the replication factor of 3 will be maintained. All right, now a quick question is, a general thought is that the user will talk to name node and name node will give him the whole file. No, the user will use something called a driver, and that driver will do a lot of heavy lifting. The driver will do slicing of the file, splitting of the file, and talking to the name node. So driver goes, so user, you as in me and you, will use this driver. This driver could be Hadoop client, or this driver could be you. So the user will talk to the driver will go to the name node, driver will go to the name node and say that, hey, I want to store this file. And name node will say, okay, don't bother me. These are the machines in the network available. Why don't you go why don't you go to those machine and store the file? Don't bother me, because you will make me the bottleneck. So name node tries its best not to become the bottleneck. So user goes to the name node stores the data in data node. That is how, sorry,
User goes to the name node tells the driver, I'm sorry, user goes to the client driver. This is a client driver. It is not a server. It is a command. So user asks this command to store the file on HDFS. Okay. Now this client goes to the name node. Hey, my user want to store this file onto HDFS. Can you tell me which machines should I go to? Name node tells client back that, see, these machines are free, so you should go to these machines. And once you are done with it, confirm to me that you have written the data. So client driver slices the data into blocks. Client driver slices the data into blocks and then start saving those blocks into data node. And once that is done, it informs name node that, hey, I am done with saving the blocks. Can you commit it? Can you update your records that it is done? Okay. Now name node will say, okay, fine, I'm done. Now what we saw just now is, this is how the HDFS works. Name node, who is just doing the accounting, as in which block of the file is where, as well as what is the size of the block left, and so on. So it does all of that for you. All right. So that is a very, very quick overview of HDFS. We will take HDFS into more details in the second session. Yes. All right. Let me answer your questions. So feel free to ask questions. I have 10 minutes. All right. So is there a step-by-step guide? I want to set up environment locally. Then download the virtual machine provided by Hortonworks. That is probably faster and you can just get it done. Second question from Maheswara: if one server goes down in a distributed system, do we keep a copy of that data of that server so that we can process the data of the down server on another server? Yes, of course. So if one server goes down, the data is anyway available on another server. That's where the replication factor of 3 comes into play. And the computation is automatically shifted by yarn onto another machine containing the same data which it was trying to process earlier. Okay, that is the magic played by yarn. Now next question from Chandra is, does the file header consider as metadata similar to RDBMS table? Where does it store? I did not get this question. Does the file header consider as metadata similar to RDBMS table? So in we here, which are we talking about, HBase? Which one are we talking about? So in Hadoop, you can store any data you want. All right. And sometimes there are these specialized format like RC file, ORC file, and there are few more formats using which you can sequence files using which you can store the data. They have the metadata header. Uh, okay. So DEE Raj question is, which certification is better from the job opportunity point of view? Databricks certification of Spark and Hadoop developer. I am already Cloudera Hadoop certified. If you are already Cloudera Hadoop certified, then I think you would not require much of a Spark certification. But if you want, Databricks certification is good. Is the 1 terabyte file really split into smaller files or stored in multiple blocks? Okay, so Mahesh's question is 1 terabyte file really split into smaller files, or is it stored in multiple blocks? So 1 TB file will be broken down into how many files? 1024 into 8 files. These many blocks. Okay, and each block will be multiplied by 3 if 3 is the replication factor. So effectively you will have 1024 into 8 into Okay, one terabyte divided by one terabyte divided by 128 MB. Okay, so these many blocks will be created. 1 gigabyte results in 8 blocks, each of 128 MB. Alright, so these many blocks. Okay, does it make sense to you, Mahesh? What happens if name node fails? So there are many ways in which you can do the name node load balancing. You generally have something called standby name node, which is always a cold copy of name node. Okay, if name node fails, you can quickly switch, or you can configure it such that it can quickly switch to the standby. Okay, but at a time there will be only one master. Now, Biswa's question is, what is the maximum limit of replication factor? Number of nodes. Okay, if you have 200 nodes, you can configure the replication factor as 200. Okay, Krishna's question is, so minimum number of nodes required in HDFS. So we need at least 4 nodes, one for name node, three for data nodes. You can also have only one node. Okay, so generally the virtual machine which people are shipping, it is generally one single node. Okay, with replication factor as 1. Also, name node, name node and data node can be run on the same machine, but not recommended in case of production. All right. The question from Rohan is, if you want to take the whole course, what are the formalities need to be completed? You can go to our website and enroll. There are not much of a formalities. Okay. Okay, Chanda is saying, does it go to data node or name node? Who? Let me try to understand your question. Okay, so controlling the logic of splitting the file into multiple blocks, who is controlling the logic? It is the client, it is the driver who does that. Like in JDBC, you have JDBC driver. Similarly, we have Hadoop driver. Okay. Mamta's question is, Mamta's question is, shouldn't the maximum number of replication factor be number of node minus one? Not really, not really. Because name node, so here when we say replication factor, it is basically a function of data nodes. Okay. And data node can be installed on the name node. Okay. So when we say replication factor is a function of available data nodes. Okay. But if you are thinking that there is one name node which is separate, then your logic is correct. In case of production, we install separately? Yes, that's very right, Sindhu. That's a very good point. We install name node and data node separately in case of production environment. All right. Wow. Okay. Is there impact on throughput by higher replication factor? Brilliant question, Biswa. Yes, there is a big impact of higher replication factor, because when you have more number of copies of the same block, there are more number of readers can read the same block at the same time. Okay, so can you explain the replication factor? Replication factor means every block will be copied that many times. We configure our Hadoop cluster for a certain replication factor. So when we are putting a file gets divided into blocks. Those blocks get copied into the network, and that each block has got a number of replicas, and that is called a replication factor. So that in case there is some nodes go down, the file is available, the data is available. Okay. Yes, we can set number the replication factor by ourselves as well. Okay. All right. One question from Jubair. We need backups as we have a distributed system. Yes, that's right. That's why we have the, okay. Krishna's question is, so when you say name node and data node are on the same machine, do you mean logical nodes? Well, so name node and data node, same machine as in same uh, computer or same virtual machine or whatever you want to call it. Okay. Sindhu's question is, will we teach installation of HDFS? No, will not be teaching installation and administration in this course. Jubair's question is, server backs up as we already have. Yes. All right. Great set of questions. And all right. So I hope I have been able to answer your questions, although it was little too much for 3 hours. All right. And if you want, I can give a demo if you can wait for 2 more minutes with me. So we have something called CloudX Lab. In environment like Amazon, we used to have our own cluster so that we could learn and experiment on the cluster so that we do not get bogged down by the installation issues. Similarly, other benefit of these kind of cloud labs is they give you the real life experience, because in real life nobody uses virtual machine. Also, distributed computing, if you want to learn, you should have a distributed computing environment, meaning multiple computers should be there in order to experiment. Okay, so that's why I did something strange, which not many people did in industry. I set a we started with we started with this creating the cluster for our student. Okay, so when you log in into our system, you will see this part of it where the information about CloudX Lab will be loaded for us. Okay, this is the login for individual person. So the first thing which you use is Ambari is the console on which uh, using which you can install the services and using which you can see the status of your server. Okay, so we log in into Ambari. All right, so you can see that these are the services that are running in our cluster. You have HDFS, MapReduce, Yarn, Hive, HBase, Pig, Scoop, Oozy, Zookeeper, and Storm, Flume, Kafka, Mohoth, and Spark. So everything is up and running in our cluster. Okay, and it shows the overall status of our cluster. Yes, this is very much similar to Sandbox, just that we have more number of hosts so that you can have a real experience of executing something on multiple number of hosts. Okay. Now, next thing which we have done is you can open the Hue. All right. You can open the Hue. We have taken the Hue from Hortonworks, and this is the Hue. And you can go into the file browser. Okay, I had already logged in into Hue. Here you can upload your file, and this here we are talking to HDFS. So you can directly upload something to the HDFS. All right. So this is what it is, and we generally store our data at a central place here, so that for our exercises you don't have to copy, upload, or hunt around for data. Similarly, this is a very big convenience for the instructor. Next is that we have something called web console, so that you don't have, if you're on the Windows, you don't have to install putty or some other system. Similarly, even if your network is blocking it, you will be still able to use uh, you will be still able to use this command prompt. Generally the SSH is blocked in companies. To overcome that, we have put it here. So from here you can interact with Hadoop using Hadoop fs command. So you can see that if you want to use Hadoop fs minus ls, it is showing my data which was there in the hdfs. Similarly, if I want to run pig, I can just type pig here and start working with pig. Okay, this is the pig console. Similarly, we have hive. This is hive console. I'm talking to hives from this console. I can execute hive commands from here. Okay, so that's pretty much with the very quick demo of our cloud lab. So we have set up all these things so that our students can start learning very, very quickly. Sindhu is saying Hue is a client driver, isn't it? Hue has got a server, a web server, using which it provides us this beautiful interface, and internally it is basically a client to the HDFS. All right. Yes, Mamta, that's right. You can say that Hue is kind of acting like a client to us. So what tools you provide in lab for MapReduce programming using Java? We provide you a full-fledged Java project which you can import to Eclipse and you can start running it. So Zubair is saying how many data nodes are there? Let's have a look at this. So how many data nodes are there? You go into HDFS. It says 6 out of 6 data node. So what we have done is we have gone a little greedy and we have put the data node and name node on the same machine. Okay, we have total 6 nodes right now. We will be adding around 20 more nodes to this cluster in upcoming 1 month. Okay. Biswa is saying normally how will be the environment in practical life at a workplace. This is how the environment will be. Generally, there are two clusters. One is called dev cluster, other is called the production cluster. Production cluster nobody generally touches, while on dev cluster people keep on experimenting. People generally avoid virtual machine in the professional environments because running a virtual machine requires a high-end machine. Similarly, if you installed it on your desktop and you want to work from home, it becomes almost impossible. That is why people avoid installing on the virtual machine. So that was pretty much for today. I'm running 10 minutes behind the schedule. So do you have any other questions, or you can just drop us an email by sending the send by basically sending the emails at this. Okay, so the course is on from tomorrow is the next class for this today's session. Tomorrow again we will cover HDFS in more details and in a more patient manner. Okay, and Apache Spark is tomorrow onwards. Okay, this is 8:30. This is all right. This is for Hadoop and this is for Spark course. There is Spark course separately, and yeah. All right. So, Praise, if you're getting an error, can you just Can you just send me the screenshot? I don't know your email ID right now. Let me try to solve it. Okay. So your name is Tracy. Okay. Let me just note it down. Tracy facing the issue. Okay. All right. When is the next class? Okay. Next class is tomorrow. Tomorrow at the same time. All right. Uh, these are time zone. This one is IST. Both of them in IST. All right. All right. So that's pretty much. I know it has been a very short and fast-paced class today. And feel free to reach out to me at reach us at no big data. If you have any questions, please reach out to me, and I'll try my best to answer your questions. So, all right. Thank you very much. So, Mahesh's question is, how will I get the access to the lab? If you enroll for the course, you will automatically get access to the lab. All right. So today was the first class, and second class is tomorrow. All right, Krishna. Today, I think today is 12th. Yeah, 12th in IST. All right. So okay. So and Mahesh, let me see if so you will get the so you should get the instructions, or if the instruction have been emailed to you, please check your spam folder once, and then it should be there. Yes, you can download the. Actually, we have a premium account from YouTube. Unfortunately, YouTube does not let you download the videos. So there are these YouTube downloaders which you can use to download our videos. Okay, you can use those YouTube downloaders. All right. All right. Thank you, Mamta. I'm happy that I was able to explain things. And yes, Baba. Yes, Biswa. For you, since you are in PST, the second class will be tomorrow morning. No, it will be tomorrow evening for you. This is Spark, not okay. This one is what we are in right now. So tomorrow, so what we call 13 December 7 a.m. in PST. How do you convert? Yeah. So it'll be 5:30 p.m. for you tomorrow. Okay. All right, thank you very much. Spark is different training session. Yes, Chandra. The Spark is a different session altogether. That will happen after around 10 hours from now. All right, thank you very much. It was a great session, great set of questions. I really enjoyed your questions. In case I have not been able to answer your question, feel free to drop in an email at reaches at no big data, and I'll try my best to explain to you. All right, so have a great day. Thank you, Abhay. Thank you, Lakshmi. Thank you, Roshan. Thank you, Prezi. Thank you, Mamta. Thank you, Yash. Thank you, Chandra. Thank you, Mahesh. Thank you, Ram. Thank you, Krishna. Thank you, Biswa. All right. All right. Okay. Okay. So Chandra would like to join the. Okay. Could you drop me an email, please? Uh, yeah. Could you drop me an email, please, for if you are looking for the first session demo for Spark? All right. I would send you immediately. I don't see your email address right now. All right. Thank you very much. Stay connected. Even if you are not planning to enroll or you've already finished your course, stay connected. If you have questions, send it to us, send it to me. Just that we are planning various different things in big data. And training is just one aspect of it. One of the things which we have done is CloudX Lab. We are providing CloudX Lab to the other people as well, to researchers and to various students independently. And we also work on real life projects with various companies. So that's another thing which we are doing, and we connect our students so they get a real time exposure sometimes. So we do that for the in the industry. All right. Okay. So, all right. It was a great session. Thank you very much. All right. So yeah, let me try to reach out to you. Yes, Prashant, you okay? All right. Thank you all, and have a great day. Bye bye.